Welcome to the webinar Functional Printing Applied to Pharma Packaging. Today we will see a new era of healthcare that brings us new needs, new trends and new opportunities to the pharmaceutical packaging industry. Then we will see new developments to pharmaceutical packaging by means of functional printing. We will see an overview of printing technologies, some examples of smart packaging, and new functional inks available commercially. Then we will review the main conclusions of this presentation. I hope this webinar will be useful for you. In this new era of healthcare, the focus is the patient, in which new prevention programs are under development, early diagnosis, triage treatment, caregiver programs, aftercare, and personal profiling. These new needs in healthcare bring us new opportunities in pharmaceutical packaging. There are some problems regarding patient adherence, security and brand protection, track and trace, cold chains, and new developments in sensors and e-labels. For example, the lack of patient adherence to prescribed medicines poses a tremendous challenge to the global healthcare community. For this kind of problems, there are new adherence interventions, for example, real-time clinical outcome, real-time data transfer, real-time communication, influence behavior, and so on. Another big problem is regarding falsified medicines and brand protections. Falsified medicines are fake medicines that pass themselves of a real or authorized medicines. Here we can see the size of the problem, but there is not only an economical problem, but also a health problem. The solutions could be integrate new functionalities to the pharmaceutical packaging, to develop smart packaging for pharmaceutical applications to solve these main problems. For that, we will see new developments by means of functional printing that can solve these main problems. We can talk about different concepts, but really are very close between them. For example, printing intelligence, functional printing, printing electronics, smart printing. The question is to use conventional printing technologies, such as we use commonly to print pharma packaging, for example, offset printing, flexography, gravure, or digital printing, such as inkjet, in which we can use conventional substrates, plastic, paper, glass, and functional inks with different conventional printings. And we can print different devices, sensors, displays, batteries, RFID tags, and so on. The question is to use these conventional printing technologies to print functional materials and functional inks into the pharmaceutical packaging. Here we can see an example of CPAC packaging to solve patient adherence. We can see another main applications to control and quality state assurance of the product, identification, traceability and real-time monitoring, security and brand protection, and innovation through communicative packaging solutions. Some solutions could be visual, or another one could transport information. For visual solutions, we can use temperature indicator, freshness, leakage indicator, or ripeness indicator. To transport information, we can use RFID antennas or 2D barcodes such as data matrix or QR codes. Here we can see some solutions regarding RFID technology, some examples to employ in pharmaceutical packaging with data matrix, or we can see some temperature indicators that are simple labels and are visual indications to monitorize the temperature of the product into the packaging. This kind of time temperature indicators could use physical systems, chemical systems, or biological systems. The question is that we can use functional inks, and we can classify mainly in chromative materials. Chromative materials are materials that change color as a result of an external phenomenon. This phenomenon can be electric current, ultraviolet, temperature, pressure, or so on. And we can classify these chromative materials in thermochromic, photochromic, or electrochromic inks. We can see here some examples of photochromic application, electrochromic, or temperature indicators or temperature applications that we can implement in pharmaceutical packaging to solve some of the different problems we saw below. There are other materials such as photoactive materials. Photoactive or photoluminescent materials are those which change occur as a result of different natural action of light or of other emitting lights. We can classify photoactive materials in electroluminescence, phosphorescence, and fluorescence. Here we can see some examples applied to packaging or signasses. And other materials are conductive materials that we can print. These are conductive inks, dielectric, semiconductors, and barrier materials. Here we can see some examples of conductive inks materials used to print RFID antennas directly to packaging applications. Finally, we are going to review the main conclusions we can consider. New needs in healthcare bring new challenges and new opportunities in pharmaceutical packaging. The market demands new functionalities and added value for the packaging to solve new problems. And we can consider these new functionalities that have to be easy to use, low cost, and we can consider conventional printing techniques such as offset, flexography, gravure, screen printing, inkjet as the best way to integrate these new functionalities into the packaging. It's possible to print new functionalities in the same way as, and at the same time we print text, images, and graphics. There are different smart inks and active materials available to print new functionalities. For example, conductive inks, conductors, semiconductors, dielectric, chromoactive inks, electrochromic, photochromic, thermochromic, photoactive inks such as electroluminescence, phosphorescence, fluorescence, and other functional inks such as magnetic inks, aromatic, and so on. Not all of these inks and materials are available for all the print technologies due to their consistency of the printing inks. And the best printing technology depends on the device you want to print, due to the type of inks, resolution, layer thickness you need to obtain. Finally, the big opportunity makes single item level change profitable. Thank you very much.